All right, so now what I want to do is I want to go through how we can evaluate a limit using a table. So in a previous example, I showed you why you can't substitute for this problem. If you tried to substitute 0 in for x, you put a 0 here and a 0 here, you get a 0 in the denominator. No bueno, that can't happen. We're not allowed to have 0 in the denominator. So, for now the fourth or fifth time at this point, the value of the function is undefined. But that doesn't mean that the limit is undefined. So what we can do to verify this is to go to the calculator. Okay? So from here, this is our old tangent graph. I'm just going to start from scratch. Oops. I'll start from scratch here. So we'll go with x over, it was the square root of x plus 1, and then on the outside, minus 1. Is that right? Okay. So here we have this function, x over radical x plus 1 minus 1. And when you look at this, we were looking at as x approaches 0. So from the graph, and I've said before, I'm on record as saying the graph's probably the worst option, and I stand by that, and you'll see why in a few examples later. But from the graph, as x approaches 0, what would you say the limit is? Okay, so again, we could go through that whole tracing process that we just did with the tangent graph, but I think it's clear to see that as you approach from the right, the y values are approaching 2, and as you approach from the left, just on this short little piece right here, as you approach from the left, the y values appear to be approaching 2. But I want you to be comfortable using a table as well. So once you've created this graph, if you hit Control T, you'll get a table. If you hit Control 6, we can look at that table separate from the graph, and that's what I'm going to do here. Now, what is the definition of a limit? A limit is an anticipated value of a function as x approaches some value. We are approaching 0. As x approaches 0, what is the y value that I would anticipate seeing? Go back to the table. As we approach 0 from the left, not from above, right? These values of x over here are getting closer and closer to 0. So as we approach 0 from the left, it's really hard to say at this point. Okay, and even here, as we approach from the right, there's no definitive answer. You're like, I don't know, they're getting smaller, maybe it's 2, maybe it's 2.25, I'm not sure. Oh wait, oh crap, oh now it's 0. So it's probably somewhere between 1 and 2.4. But it's not a very precise measurement at this point. So what we want to do is change our table settings. So hit Menu, Table, Edit Table Settings. Now, your table start should be what x is approaching. If x is approaching 0, start your table at 0. You may say, why don't I start it a little bit to the left or a little bit to the right? We're going to be able to see that movement anyway. The table step is what's most important. The more microscopic we can get, the better idea we're going to have about what this value is approaching. 1 is too big. Relatively speaking, it's too big. We want to be pretty precise. I would say no less than 1,000. Okay? Or no greater than 1,000, should I say. So if we use 1/1000, now when you look, as these values so incredibly close to 0 approaching from the left, what are these numbers clearly approaching? Now you can definitively say, okay, so stop right here. If I push down one more time, what are you going to expect to see? What would you anticipate seeing if I push down here? Because if I push down one more time, x is going to be 0. What would the y be? You see these numbers are getting just a little bit bigger. So what would you anticipate seeing? 2. What do we see? Nothing. Undefined. But that's the foundation of limits. That's the one thing that I'm trying to get across to you guys right now is it doesn't matter that says undefined. Right before I clicked down, you could have said, oh, I think it's going to be 2. And that's what a limit is, the anticipated value. Undefined, immaterial, doesn't matter. You anticipated seeing a 2 there. The fact that there's not a 2 there doesn't matter. As we approach from the right, as we approach from the right, as these values get smaller and smaller and we're getting closer to 0, these numbers are getting closer and closer to 2. So when I push up, what would you expect to see? 2. And the fact that it was getting close to 2 from both sides, that's important. So that's tabularly speaking, when you look at a table, it doesn't matter what's in this square right here. It matters what you thought you were going to see as you came from this side and as you came from this side. And if it's the same number, that's why we can say in this case, we can erase this. We don't know. We do know. We know that the value of this limit is 2. Purely coincidental that it's equivalent to the one that we saw here. Not every value and not every limit is equal to 2, but this is one way that we can do it using a table.